3I Atlas was meant to be alone, a solitary wanderer from the stars. But the universe had other plans. Now, C2025 V1 Borisov appears, threading a path directly between it and Earth, mirror-like in trajectory, tailless, and unnaturally bright. Coincidence or cosmic coordination? Some scientists whisper of a shared origin, fragments of a shattered parent, a hidden stream of interstellar debris, or something far stranger. Tonight, we follow their paths, uncover anomalies that defy explanation, and confront the unease spreading through the scientific community.
Hold on, because the story of these twin interstellar visitors is just beginning, and what unfolds next is far more unsettling and nothing we were ever prepared for. If this mystery has you hooked the way it has me, make sure to hit like and subscribe so you don't miss a single update as this unfolds in real time. Picture this, somewhere out beyond the familiar arc of our solar system, something moves. Not one of ours, not bound to our sun, a visitor from another star, sliding through the darkness at impossible speeds, unannounced and utterly alien.
On July 1, 2025, astronomers using the Atlas Survey Telescope in Chile spotted exactly that. They called it 3I Atlas, and for a brief moment we thought we understood what we were looking at. Just another interstellar comet, right? A cosmic tourist passing through our neighborhood? Rare, sure. Fascinating, absolutely. But explainable. Then something happened that changed everything. Another object appeared. Not weeks later, not months later, days later.
This one they're calling C/2025 V1 Borisov. And here's where your skin should start to prickle. It showed up in the same cosmic corridor, same trajectory class, same impossible speed, same strange properties. And it positioned itself directly between 3I Atlas and Earth like it was cutting in line at the universe's most exclusive event. Two interstellar visitors. Same cosmic highway, same era, same neighborhood. Are you starting to see the problem? Let me paint a picture of what normal looks like in our solar system. Comets are predictable creatures.
They orbit the sun in long elliptical paths bound by gravity like planets on a leash. As they approach the warmth of our star, their icy surfaces boil off, creating those spectacular tails we've admired since ancient times. They brighten, they glow, they perform. We can predict them decades in advance because they're locked into our system, playing by our rules. 3I Atlas plays by different rules entirely. Its trajectory is hyperbolic. That's astronomer speak for this thing is not sticking around. It's moving at roughly 60 kilometers per second relative to the sun. That's not orbital velocity.
That's escape velocity on steroids. This object came from somewhere else, and it's going somewhere else, and our solar system is just a brief stopover on a journey that began before our sun was born. It will pass through, wave politely, and vanish back into the infinite dark between stars. But now there are two of them doing this. Two objects exhibiting nearly identical behavior showing up in the same patch of sky within the same narrow window of time. Think about the scale we're talking about here. Space is preposterously, incomprehensibly large.
The odds of two independent objects from interstellar space randomly arriving at the same time from roughly the same direction exhibiting the same unusual properties? The numbers don't favor coincidence. A researcher at the Jet Propulsion Laboratory put it to me this way, off the record. It's like watching two messengers walk through the same open door minutes apart. Maybe they don't know each other, maybe it's pure chance. But you'd be stupid not to ask if someone sent them both. So what are we looking at? The boring answer is that we're witnessing a statistical fluke. Two totally unrelated chunks of ancient ice and rock that just happen to aim themselves at our solar system from similar angles at similar times. It's possible. Space is weird. Weird things happen. But the more you look at the data, the harder that explanation becomes to swallow. Because we're not just talking about timing here, we're talking about behavior. 3i Atlas doesn't act like the comets we know. Its brightness fluctuates in ways we don't expect. Its color is wrong, shifted toward glue in a manner that suggests something unusual about its composition or surface properties.
And now we have a second object showing up with remarkably similar characteristics, threading the needle of space to place itself precisely between the first visitor and our planet. That's not just unusual, that's geometrically suspicious. Think about it this way. You're sitting in your house when a stranger walks up your driveway. Odd, but maybe they're lost. Then, 5 minutes later, a second stranger walks up the exact same driveway, following the exact same path. Still think they're both lost? Or is it time to admit that your driveway might be on some kind of map?
The solar system just became a driveway. What we're looking at here is the end of an era. Up until July 2025, interstellar objects were theoretical curiosities. We'd seen one before, Oumuamua, back in 2017, and that was strange enough to spawn 1,000 papers and 100 conspiracy theories. But one object can be an accident, an anomaly, a fluke. Two objects, arriving together, exhibiting coordinated geometry, that's not an anomaly anymore. That's a pattern. And patterns in space terrify scientists, because patterns mean processes. Processes mean causes. Causes mean something is happening that we didn't predict, don't understand, and can't control. We're no longer looking at a freak one-off event. We're looking at what might be a stream, a trail, a flow of material moving through our solar system from origins we can't identify. This is where the questions get uncomfortable. If these two objects are related, what broke them apart? When did it happen? Where did they come from? And here's the one that keeps astronomers awake at 3 in the morning. Are there more coming? Because if this is a stream, if this is debris from some larger event or structure, then what we're seeing right now might just be the leading edge, the vanguard, the first scouts crossing our border before the main force arrives. We might be standing at the cosmic equivalent of a railroad crossing, watching the first two cars of a very, very long train roll past. Whether it's being used deliberately and what exactly is on the other side. In the sections ahead, we're going to pull apart this mystery piece by piece. We'll examine the geometry that makes scientists nervous. We'll explore the parent body hypothesis and what kind of monster might have shattered to produce these fragments. We'll look at the strange behaviors that don't fit any comet model we have. And yes, we'll venture into the controversial territory that professional astronomers whisper about, but rarely publish. But first, we need to understand exactly why the math here is so disturbing. Why two objects in the same corridor shouldn't be possible. And why, if it is possible, we might need to rethink everything we thought we knew about how safe and empty the space around us really is. What if the void isn't empty? What if the silence between stars has been hiding something all along? What if we've been waiting for visitors, and the visitors have finally arrived? The ambush has begun. Numbers don't lie, but sometimes they whisper things we'd rather not hear. 3i Atlas reached its closest point to the Sun, what astronomers call perihelion, on October 30th, 2025, at a distance of about 1.4 astronomical units. That's roughly 130 million miles, positioned comfortably outside Earth's orbit. Its closest approach to Earth came in at about 1.8 astronomical units. Close enough to study, far enough to be safe. On paper, it's just another object passing through. But that trajectory tells a different story. A hyperbolic trajectory means this object is gravitationally unbound from our Sun. Think of it like this. Most objects in our solar system are on elliptical orbits, looping around the sun like horses on a carousel, forever circling, forever returning. A hyperbolic trajectory is the path of something that arrives at the carousel, cuts straight through the middle, and exits the other side without ever slowing down. It's the path of a visitor who never intended to stay. 3I Atlas came from somewhere beyond our solar system, and it's heading back out there.
But here's where the geometry starts to get uncomfortable. The second object, C/2025 V1 Borisov, appeared on a trajectory that places it spatially between 3I Atlas and Earth. Not just vaguely in the same region of sky, directly between, threading the cosmic needle with precision that makes orbital mechanics experts raise their eyebrows and start running improbability calculations. Two objects, similar trajectories, staggered timing, geometrically aligned. The odds of this happening by pure chance are not zero, but they're not comfortable either.
Let's talk about direction for a moment, because direction matters when you're trying to figure out where something came from. 3I Atlas approached from the direction of Sagittarius, that constellation that sits toward the center of our galaxy. But here's the kicker. Its orbital inclination is roughly 175 degrees. In plain English, that means it's moving retrograde, backward relative to the plane of our solar system, coming in at a steep angle that cuts against the grain of how everything in our neighborhood moves. This is strange for a couple of reasons.
First, astronomers expected interstellar objects to arrive from random directions, distributed more or less evenly across the sky. That's what isotropic means in the trade, a smooth, random distribution from all angles. But 3I Atlas came from a specific direction that wasn't predicted, charging up from the southern celestial hemisphere with the trajectory of something that has somewhere specific to go. Second, when you factor in the arrival of the second object from a similar direction, the isotropy assumption starts to crack. Random arrivals shouldn't cluster, they shouldn't correlate, they shouldn't line up like runners on a track.
But that's increasingly what the data suggests is happening. Imagine standing in an open field. You're told that occasionally, randomly, a runner might sprint past you from any direction at any time. That's the old model of interstellar visitors. Rare, random, unpredictable. Then in the same afternoon, two runners sprint past you on nearly parallel lines seconds apart, both coming from the same tree line. Are you still thinking random? Or are you starting to think there's a starting line somewhere in those trees that you can't see? The field is our solar system. The tree line is interstellar space. And something just fired the starting pistol. Now let's add another wrinkle. Brightness. 3I Atlas brightened in ways that surprised observers. It showed unusual color properties, appearing distinctly bluer than the sun in some observations, suggesting either exotic composition or unusual surface materials. There was talk of rapid brightening events, sudden flares of activity that don't match standard comet outgassing models. Objects that come from the frozen darkness between stars aren't supposed to wake up and start performing like this. Unless, of course, they're not just ice and rock. Unless their composition includes materials we don't have analogs for. Unless they're fragments of something that behaved very differently from the comets we've studied for centuries. And now we have two of them, exhibiting similar anomalies, traveling similar paths. Let's lay out the possible explanations, from most boring to most unsettling. First possibility, shared progenitor. These two objects were once part of a larger body, something that broke apart at some point in its journey through space. Fragmentation events happen. We've seen comets split in our own solar system, most famously Shoemaker-Levy, which shattered into more than 20 pieces before slamming into Jupiter. If 3I Atlas and its companion were born from a common parent, that would explain their similar trajectories and timing. They're siblings, fragments of a cosmic breakup that happened long ago, now arriving at our doorstep together after millions or billions of years of drift. Second possibility, interstellar stream. Instead of two objects, we're looking at a ribbon or trail of debris, like the dust lanes that produce meteor showers when Earth passes through them. Except this stream comes from interstellar space, possibly shed by something massive that passed through our neighborhood eons ago.
We're seeing the brightest chunks first, but there could be dozens or hundreds more fragments spread along the same corridor, too small or too dark to detect yet. Third possibility, gravitational focusing. Some unknown massive object or gravitational anomaly bent multiple interstellar objects onto similar paths, like light bending around a lens. This could be a rogue planet, a brown dwarf, or even a small black hole drifting through our region of the galaxy, warping trajectories in ways we haven't mapped. Fourth possibility, something is organizing them.
This is where we leave the comfortable territory of conventional astrophysics and venture into the realm of ideas that don't make it into press releases. What if these objects aren't randomly arriving? What if their alignment is deliberate? What if something, natural or otherwise, is directing material through specific corridors for specific reasons? That last possibility is the one that makes scientists uncomfortable at conferences, not because it's impossible, but because it opens doors to speculation that careers can't afford. But the data increasingly demands that we at least hold the door open and peek through. Spatial clustering of interstellar arrivals should be unlikely if the universe is truly random at this scale. But two objects, same corridors, same timing, exhibiting strange behaviors that defy standard models? That's not random, that's structured. And structure implies organization. Organization implies cause. Someone once told me that the scariest moment in astronomy isn't when you see something you can't explain. It's when you see something that shouldn't be possible, and then you see it again. Repetition turns anomalies into patterns. Patterns turn mysteries into threats. Because if it can happen twice, it can happen a third time, a fourth,
100th. The geometry of 3I Atlas and its companion is beginning to look less like an accident and more like an arrival. Not a random cosmic accident, but an entrance, a procession. Two messengers walking through the same door, carrying information we don't yet know how to read. And if they're messengers, the next question becomes, what message are they carrying? What happens when we decode the geometry and realize these objects aren't just passing through? What happens when we understand that the corridor they're traveling is a highway? And highways go both ways.
The numbers whisper that something is coming. The geometry suggests it's organized. The timing implies it's already here. And that's just the surface of the problem. Because when you start digging into what these objects are made of, how they're behaving, and what might have produced them, the geometry problem becomes the least of our worries. What if these visitors aren't whole objects at all? What if they're fragments? Pieces of something much, much larger that broke apart somewhere out there in the dark? What if the parent body is still coming? Sometimes the pieces tell you more about the original than the original ever could. When you find two identical arrowheads at an archaeological site, you don't assume two different craftsmen independently invented the exact same design. You assume one toolmaker, one workshop, one source. The fragments point back to something whole, something intentional, something that came before. So here's the question keeping planetary scientists awake. What if 3I Atlas and its companion aren't separate entities at all? What if they're fragments? Shards of something vastly larger that shattered somewhere in the darkness between stars, sending pieces of itself spiraling through space on trajectories that just happen to converge on our tiny patch of the cosmos.
In our solar system, we've watched fragmentation play out in real time. Comet Shoemaker-Levy 9 is the textbook example. In 1992, Jupiter's immense gravity ripped that comet into more than 20 distinct fragments, which then slammed into the planet in a sequence of impacts that left scars visible from Earth. The forces involved were purely gravitational, purely natural, and absolutely spectacular in their violence. A comet became a shotgun blast of ice and rock, each piece following a slightly different path, but all originating from the same parent body. Now scale that up, way up. Imagine not a comet passing too close to a planet, but something massive, potentially tens or hundreds of kilometers across, encountering forces in deep interstellar space that we can barely model. Maybe it passed too close to a star during its billions of years of drift. Maybe it collided with another rogue body in the darkness between solar systems.
Maybe something about its composition, some exotic ice or volatile material, reached a critical temperature or pressure threshold and simply tore itself apart from internal forces we don't fully understand. Whatever the mechanism, the result would be the same. A parent body becomes a debris field. A single massive object transforms into a train of fragments, all following similar but not identical paths, spread out along the original trajectory like boxcars disconnected from their engine. The engine, the parent body, might be long gone, vaporized or flung onto a different path.
But the trail remains, stretching across light years, a cosmic breadcrumb line, pointing back to an origin we can only infer. This is the dust train model, and it fits uncomfortably well with what we're seeing. 3I Atlas displays properties that suggest it's not a pristine, intact object. Polarimetric observations, which measure how light scatters off the object's surface, show extreme negative polarization. That's a technical way of saying the material on this thing behaves in ways we don't normally see in comets. The surface could be covered in unusual dust grains, exotic ices, or materials that formed under conditions completely alien to our solar system's chemistry. It's not behaving like a comet, it's behaving like a fragment of something else. And fragments, by definition, imply a whole that no longer exists. If 3I Atlas and C/2019 1V Borisov are siblings, pieces of a shattered parent, then the logical next question is, where are the other siblings? Fragmentation events don't produce two pieces. They produce dozens, hundreds.
Depending on the size and composition of the original body, we could be looking at an entire swarm of interstellar debris, most of it too small or too dark to detect with current instruments, all drifting through our solar system on parallel trajectories that we haven't mapped yet. Think about that for a moment. The two objects we've spotted might be the visible tip of a much larger iceberg. An iceberg that's currently passing through our neighborhood, mostly invisible, carrying with it materials and properties that originated in a stellar system we'll never identify, created under conditions we can't replicate, billions of years ago, when our own planet was still a molten ball of rock cooling in the darkness. The timeline here is staggering. If this debris field was created by a fragmentation event near another star, the fragments would have been ejected billions of years ago. They've been drifting through the galaxy ever since, moving at speeds that make our fastest spacecraft look like they're standing still. The parent body, if it still exists, could be light years away by now, or it could have been completely destroyed, reduced to dust and gas that's long since dispersed into the interstellar medium. But the fragments remember. They carry the chemical fingerprints of their origin. They preserve information about a world or system we'll never visit, encoded in their ice and rock and dust. If we could capture one of these objects, bring it into a lab, analyze its composition, we'd be holding a message in a bottle from another star. A time capsule from an alien solar system, delivered to our doorstep by chance and physics and time. Except it might not be chance. And that's where this hypothesis starts to get genuinely disturbing. Because if there's a stream of fragments passing through our solar system, and if those fragments originated from a single massive parent body,
then we have to ask what that parent body was. Was it just a large comet or asteroid, a natural accumulation of ice and rock that happened to grow big before something shattered it? Or was it something else, something more complex? Something with internal structure, deliberate composition, maybe even purpose? I know what you're thinking. You're thinking I'm about to suggest that these fragments are pieces of an alien spacecraft or probe or artifact. And look, I'm not saying that. The scientific community isn't saying that. The data doesn't support that conclusion. But the data also doesn't rule it out. And that's the uncomfortable part. We're looking at objects that don't behave like normal comets, that arrived in suspicious geometric alignment, that exhibit properties we can't fully explain with conventional models.
At what point do we acknowledge that the parent body hypothesis doesn't just allow for exotic natural materials, but potentially exotic artificial ones? This is where the conversation usually stops at conferences. Someone will say, "We need more data," and everyone nods and the subject changes. But in private, over coffee or beer, the speculations come out. What if the parent body was manufactured? What if we're seeing debris from something that was built, not born?
What if the stream of fragments passing through our system includes not just ice and rock, but materials that were engineered, designed, constructed by intelligences that died out before our sun ignited? That's the fringe interpretation, the one that gets you uninvited from academic panels. But it's also the interpretation that some very smart, very credible people are quietly considering. Because the alternative, that these are just natural objects behaving in highly improbable ways, requires us to accept a level of coincidence that statistics don't favor. Here's what we know for certain. Something broke apart. Something massive. Something that sent at least 2 detectable fragments on trajectories that aimed them directly at our solar system. Those fragments are here now, sliding through our neighborhood with properties that defy easy categorization. And if the parent body hypothesis is correct, more fragments could be inbound, potentially dozens or hundreds of them, spanning a debris field that might take years or decades to fully traverse our system. What we don't know is what that parent body was, where it came from, or why it broke apart. We don't know if the fragmentation was natural or artificial. We don't know if the trajectory through our solar system was intentional or accidental. And we don't know what other surprises might be hiding in the tail of this cosmic train. But we're about to find out, because as more telescopes turn toward these objects, as more data accumulates, as artificial intelligence systems start pattern matching against databases of known phenomena, we're going to start seeing details that have been invisible until now. We're going to get chemical spectra, thermal signatures, structural imaging. We're going to see what these fragments are made of. And when we do, we'll know whether we're looking at chunks of ancient ice from a dead star system or something infinitely stranger. The parent body, whatever it was, is gone. But its children are here, and children always carry traces of their lineage, encoded in their bones and blood and memory. We just need to learn how to read them. We just need to be prepared for what those traces might tell us. Because if the parent was natural, then we're witnessing a rare but explicable cosmic event. But if the parent was something else, if it was designed, if it was sent, then these fragments aren't debris at all. They're artifacts, evidence, proof that we're not alone, and never have been, proof that the space between stars isn't empty, but filled with the remnants of histories we can't begin to comprehend, proof that someone, somewhere, a very long time ago, built something so large and so complex that even its shattered remains can cross the galaxy and arrive at our door, bearing messages we don't yet know how to decode. The monster is gone. But a shadow just passed between us and the sun. And shadows, as any child knows, means something real is casting them. Something that might be closer than we think. Something that might still be watching. Something that might not be finished with us yet. What comes next isn't about finding more fragments. It's about understanding what the fragments are fragments of, and whether we're ready for that answer. Comets are supposed to be simple. You heat ice, it vaporizes. Gas and dust spray out in a glowing envelope we call a coma. Solar wind pushes the debris into a tail that always points away from the sun. It's elegant, predictable. We've been watching comets do this dance for thousands of years. It's in the textbooks, it's settled science. Except when it's not. 3i Atlas looked at those textbooks and decided to improvise. Early observations showed something profoundly wrong with this object's behavior.
Where there should have been a clear, bright tail of gas and dust pointing away from the sun, there was almost nothing. Or worse, there was something, but it was pointing in the wrong direction. Multiple observation teams reported what they're cautiously calling an anti-tail, a stream of material that appears to be oriented toward the sun instead of away from it. That shouldn't be possible according to standard physics. Solar radiation pressure and solar wind should push material outward, not inward.
Yet there it was, captured in images from the Keck 2 telescope, material moving the wrong way, doing the wrong thing, breaking the rules. Then there's the color problem. Comets typically appear reddish or neutral in color, reflecting sunlight in ways that match their dusty, rocky composition. 3i Atlas appears distinctly bluer than the sun in spectroscopic observations. That blue shift suggests the presence of specific gases, possibly carbon monoxide or carbon dioxide, being released in quantities and ratios that don't match what we see in solar system comets. It's outgassing, sure, but it's outgassing materials in proportions that suggest a completely different formation history, a different chemical environment, possibly a different stellar system with different abundances of elements than our own. And the brightening. Oh, the brightening. Comets brighten as they approach the sun, because solar heat vaporizes surface ices, releasing more gas and dust that reflects more sunlight. The relationship is predictable, calculable. You can model it with equations that work for every comet we've studied. 3i Atlas brightened faster than those equations predicted. Not slightly faster, significantly faster. Like something inside it was waking up, responding to solar heat in ways that suggest either a composition we don't understand or a structure that's more complex than a simple dirty snowball. Some observers started whispering about something even stranger, the possibility of a reflective coating. Imagine the surface of this object covered in a thin layer of highly reflective material, maybe metallic grains sintered together by cosmic radiation over millions of years, or carbon compounds arranged in crystalline structures that act like mirrors. Such a coating would increase the object's albedo, its reflectivity, making it appear brighter than its size and composition alone would predict. It would also explain some of the anomalous color signatures, the unusual polarization properties, the way light bounces off this thing in patterns that don't match standard comet models. But here's the uncomfortable part. Coatings don't just form randomly. In nature, you need specific conditions, specific processes to create uniform surface layers. On asteroids and comets in our solar system, surfaces are jumbled chaos. Craters and boulders and regolith mixed together without order. A reflective coating implies organization at the microscopic level. It implies processes that sort and arrange materials. It implies, if you want to follow the logic to its uncomfortable conclusion, engineering. There's another anomaly showing up in the trajectory data: non-gravitational acceleration. This is when an object's motion deviates slightly from the path pure gravity would dictate. In normal comets, this happens because outgassing jets act like tiny rocket engines, pushing the object in directions that gravity alone wouldn't produce. The effect is well understood and can be modeled. 3I Atlas shows signs of non-gravitational acceleration, but the magnitude and direction don't cleanly match standard outgassing models. Something is pushing it, or something inside it is shifting mass in ways that alter its path. We can measure the effect. We can't fully explain it. A researcher I spoke with joked that 3I Atlas looks like a probe trying to look like a comet, but badly. They laughed when they said it, but the joke carried weight. Because that's exactly what you'd expect if something artificial was trying to blend in using passive materials. If some ancient mechanism was coasting through space with just enough active control to maintain trajectory, but not enough power to fully hide its non-natural characteristics, you'd see anomalies, contradictions, behaviors that almost fit natural models, but deviate in subtle, persistent ways. I need to be clear here. Mainstream science is not endorsing artificial origin theories. The official position is that these anomalies, while unusual, can likely be explained by uncommon but natural processes.
Maybe 3I Atlas formed in a region of its parent stellar system where carbon monoxide ice was more abundant than water ice. Maybe it has internal voids or chambers that channel outgassing in unexpected directions. Maybe its surface has been processed by cosmic rays in ways that created unusual reflective properties. All of these are plausible. All of these are under investigation. But plausible doesn't mean confirmed. And as more data comes in, as more observations accumulate, the list of natural explanations keeps growing longer and more complex.
Scientists are having to invoke more and more special conditions, more and more unlikely scenarios to account for everything this object is doing. And there's a principle in science called Occam's razor that says when you need a dozen complicated explanations to account for something, maybe you should consider whether there's one simple explanation you've been avoiding. What if it's not a comet? What if we've been trying to fit this object into the wrong category from the beginning?
What if 3I Atlas and its companion are something else entirely, something we don't have a name for yet, something that doesn't fit cleanly into our taxonomy of solar system bodies? The coma that isn't quite a coma, the tail that points the wrong way, the colors that don't match, the brightness that exceeds predictions, the acceleration that deviates from pure gravity, these aren't just curiosities, they're signatures, fingerprints, evidence that we're dealing with something outside our experience, something that our models weren't designed to accommodate.
And here's what really keeps me up at night. If one object shows these anomalies, it could be a fluke, a statistical outlier, nature experimenting with edge cases. But now we have two objects, both showing similar weird behaviors, both arriving in the same cosmic corridor. When anomalies cluster, they stop being anomalies. They become a pattern. And patterns mean something systematic is happening. Either there's a class of interstellar objects we've never encountered before, objects with properties and behaviors that don't match anything in our solar system, objects formed under such alien conditions that they break all our expectations. Or we're looking at something that was designed to break those expectations. Something that mimics natural objects just enough to pass casual inspection, but reveals its true nature when you look closely at the details. Something that wants to be seen but not recognized. I don't know which possibility is more unsettling. Natural objects that defy explanation force us to admit how little we understand about planetary formation and composition beyond our immediate neighborhood. Artificial objects force us to admit that we're not the first intelligence in the galaxy, and that whatever came before us had technology sufficient to launch objects on journeys across interstellar space that last billions of years. Either way, we're standing at a threshold. The old certainties are crumbling. The comfortable assumption that interstellar visitors would behave like oversized asteroids or comets has been shattered by objects that refuse to play by our rules. We're in new territory now, territory where the map is blank and the compass doesn't point north. What comes next is even stranger.
Because while scientists are puzzling over anti-tails and blue shifts and non-gravitational accelerations, there are conversations happening in back rooms and private emails and locked conference sessions that don't make it into press releases. Conversations about what these anomalies might actually mean. Conversations about worst-case scenarios and best-case scenarios, and scenarios so weird that careers can end just from mentioning them out loud. That's where we're going next, into the controversial stuff. The theories that challenge not just our understanding of comets, but our understanding of our place in the universe.
The ideas that scientists whisper about, but won't defend in journals. The possibilities that, if true, would change everything we think we know about the silence between stars and whether that silence has ever been broken. Because if 3I Atlas isn't a comet, if these objects aren't natural debris, then we need to start asking very different questions. Not what are they made of, but who made them? Not where did they come from, but why did they come here? Not are there more, but what happens when they arrive? The coma that isn't a coma might be something else. A shell, a facade, a costume. And costumes are worn for a reason, either to protect what's inside or to disguise it. Maybe both. The outlier signatures aren't bugs. They might be features, intentional deviations from natural behavior, left visible as markers for anyone smart enough to notice. Breadcrumbs leading toward a truth we're not ready for, but can't avoid. The question is whether we have the courage to follow those breadcrumbs where they lead, or whether we'll keep pretending these are just comets that happen to be really, really weird. Either way, the data's in. The anomalies are confirmed. Something is different about these visitors. Something fundamental. Something that demands answers we might not be prepared to hear. And the clock is ticking, because more objects could be arriving any day now. More fragments, more siblings, more pieces of whatever 3I Atlas used to be part of, or whatever it was sent to find.
We're not passive observers anymore. We're participants in something larger, something that started long before we evolved and might continue long after we're gone. The outlier signatures are calling cards. The question is who left them and what they want us to know. There are 3 conversations happening right now about 3I Atlas and its companion. The first conversation is public. Peer-reviewed papers, conference presentations, NASA press briefings where carefully worded statements describe unusual but potentially explicable phenomena.
The second conversation is semi-public. Emails between researchers, late-night discussions at observatories, coffee break speculation where scientists let their guard down just enough to admit that something here doesn't add up. The third conversation happens in whispers, in encrypted messages, in phone calls where people check to make sure no one else is listening. That's the conversation we need to talk about now. Let's start with the most plausible fringe theory. Not something in the sense of intelligent direction necessarily, but something in the sense of a natural process we haven't identified yet. Maybe there's a gravitational river in this region of the galaxy, a stable flow pattern created by the combined mass of nearby stars that funnels interstellar debris along specific paths. Maybe these objects were captured by that flow millions of years ago, and it's only now that their trajectories happen to intersect our solar system. The geometry we're seeing isn't coordination, it's channeling.
Like water flowing downhill through the same valley, not because the water is organized, but because the landscape gives it no other choice. This theory has merit. Gravitational assists and slingshot effects are well understood in orbital mechanics. Scale those effects up to galactic distances, add in the gravitational influence of dark matter structures we can't directly observe, and you could potentially create corridors or streams where interstellar objects preferentially travel. It would explain the clustering without requiring anything exotic. But it doesn't explain the timing.
It doesn't explain why these objects showed up now, in this brief window when we happen to have telescopes capable of detecting them.
The universe is 14 billion years old. Our civilization has had telescopes for a few hundred years. The odds that a natural gravitational channel would deliver multiple interstellar objects to our neighborhood during the exact century when we're capable of noticing? That's a coincidence that stretches probability to its breaking point. The second theory is darker. Long-range artificial debris. Not active probes, not functioning spacecraft, just junk. The dead remains of technologies that stopped working millions or billions of years ago, now drifting through the galaxy like ghost ships, following trajectories set by civilizations that have long since gone extinct. Under this model, 3I Atlas and its companion are pieces of someone else's trash, launched into interstellar space for reasons we can only guess at. Maybe they were part of a vast network of communication relays that went offline when their builders died out. Maybe they were mining equipment, resource gatherers sent to extract materials from other star systems and never recalled. Maybe they were weapons, or shields, or monuments, or things we don't have concepts for because our technology hasn't reached that level yet. The appeal of this theory is that it explains the anomalies without requiring anything to still be actively controlling these objects. Dead technology can still exhibit non-natural properties. A derelict probe with reflective coating would still show unusual albedo. Defunct mechanisms could still cause non-gravitational acceleration as internal components slowly degrade and vent stored gases. The strange behaviors we're seeing wouldn't be intentional. They'd be artifacts of decay, the death rattles of machines that stopped functioning eons ago but haven't fully decomposed yet. But the theory that really makes establishment scientists uncomfortable is the third one: interstellar beacon chain. The idea that these objects aren't debris at all, aren't fragments, aren't dead junk. The idea that they're active, functional, part of a network, nodes in a lattice that spans the galaxy, placed deliberately along specific corridors to mark routes, or store information, or relay signals between distant points. Under this model, 3I Atlas and its companion are like lighthouses, beacons, designed to be noticed by anyone with telescopes capable of seeing them. The unusual properties, the anomalous behaviors, the geometric alignment aren't accidents or malfunctions. They're features, signals. We are here. We are not random. We are part of something larger. This is where peer review ends and career risk begins. Because if you publish a paper suggesting that interstellar objects might be part of an artificial navigation network, you will be laughed out of academia. Your grant funding will evaporate. Your university might quietly suggest you'd be happier somewhere else. The scientific establishment has very strong immune responses to ideas that sound too much like science fiction, even when the data supporting those ideas is solid. But some people are saying it anyway. Avi Loeb, the former chair of Harvard's astronomy department, has publicly accused NASA of hiding critical images of 3I Atlas that could support non-natural origin claims. Whether his accusations are justified is debatable. What's not debatable is that they've opened a door that many scientists would prefer to keep closed. Because once you admit that artificial origin is even a possibility worth investigating, you're admitting that the universe might be far more crowded than we've assumed. That the silence we've interpreted as emptiness might actually be a failure of our listening apparatus. That we might be surrounded by relics and ruins and active mechanisms from civilizations we can't comprehend, and we've been too parochial, too limited in our thinking to recognize them. SETI, the search for extraterrestrial intelligence, has traditionally focused on radio signals. The assumption was that advanced civilizations would communicate using electromagnetic radiation, broadcasting their presence across the galaxy in ways we could detect with radio telescopes. But what if that assumption is wrong? What if advanced civilizations don't broadcast at all? What if they build physical infrastructure instead? Chains of objects placed along useful routes, markers left in high-traffic areas where emerging civilizations might eventually develop the technology to notice them.
If you're a galactic civilization trying to make contact with emerging species, radio broadcasts are inefficient.
They require precise timing, precise aim, and the receiving civilization needs to be listening at exactly the right frequency, at exactly the right time. But physical objects persist. They remain visible for millions of years. They can be examined, studied, analyzed by any civilization that develops telescopes and orbital mechanics. They're patient. They wait. And when you finally notice them, when you finally develop the tools to see their anomalous properties, that's the moment of contact. Not first contact in the sense of conversation, but first contact in the sense of recognition.
The moment when you realize you're not alone because someone left evidence for you to find. The mainstream scientific position is that we need more data before we can draw any conclusions. That's reasonable. That's responsible. But it's also, potentially, a delay tactic. Because more data means more time to prepare institutional responses, more time to game out scenarios, more time to control the narrative before the public fully grasps what we might be looking at. Let me be clear. I'm not saying these objects are definitely artificial. I'm not saying they're definitely part of an alien network. The evidence is ambiguous. The data could support multiple interpretations. What I am saying is that the possibility is on the table now in ways it wasn't before. And the fact that serious scientists are even considering these interpretations, even in private, even in whispers, tells you how far outside normal bounds these objects have pushed us. There's a reason these conversations don't make it into press releases. It's not censorship, exactly. It's institutional caution. NASA's job is to explore space and report findings, not to trigger societal panic or upend philosophical foundations.
If there is even a chance that these objects are artificial, that knowledge needs to be rolled out carefully, with context, with preparation, with international coordination. You don't wake up humanity with a megaphone. You do it gradually, with escalating hints, letting people adjust to each new revelation before dropping the next one. But the problem with gradual revelation is that it looks a lot like hiding information. And when people suspect information is being hidden, trust evaporates. Conspiracy theories flourish. The conversation splits into camps: those who trust official narratives and those who assume everything official is a lie.
The middle ground collapses, and that's exactly what's starting to happen now as amateur astronomers and independent researchers analyze publicly available data and come to conclusions that don't match the carefully worded official statements. The truth is probably somewhere in the messy middle. These objects are probably natural in origin, but with properties so unusual that they mimic artificial characteristics. Or they're probably artificial, but so old and degraded that they barely function anymore. Or they're probably something we don't have a category for yet, something that challenges our binary thinking about natural versus artificial, alive versus dead, intentional versus random. What we can say with confidence is that Triae Atlas and its companion are not behaving like standard comets. They're exhibiting properties that demand explanation. Multiple possible explanations exist, ranging from conventional to exotic to paradigm-shattering. And the clustering, the geometric alignment, the timing, all suggest that whatever is happening here is not a one-time event. It's part of a pattern, a process. Something that's been going on for a very long time, and we're only now developing the tools to perceive it. The controversial stuff scientists won't put in press releases isn't crazy. It's uncomfortable. It's destabilizing. It forces us to question assumptions we've held for centuries about our place in the cosmos, about whether the silence between stars is truly empty or just incomprehensibly crowded with things we haven't learned to recognize yet. And here's the final uncomfortable thought. If these objects are part of a network, if they're markers or beacons or nodes in some larger system,
then their presence in our solar system might not be passive observation. It might be active engagement. The moment we developed telescopes capable of seeing them might have been the moment we triggered a response. Not an immediate response, not something that happens on human timescales, but a response nonetheless. A signal sent somewhere, a flag raised, a notation made, civilization detected, observational capacity confirmed, proceed to next phase. What's the next phase?
Nobody knows. Maybe nothing. Maybe we're just another data point in someone's long-term census of galactic civilizations. Or maybe the next phase involves more visitors, more obvious ones, objects that can't be explained away as comets or debris or fragments, objects that force us to confront truths we've been avoiding. The controversial theories aren't predictions, they're preparations, ways of thinking about possibilities before those possibilities become certainties. Because if this is a beacon chain, if we're being watched, if the objects in our solar system are tests or markers or invitations, then our response matters.
What we do next, how we interpret this evidence, whether we acknowledge the implications or continue pretending these are just weird rocks from space, that choice might determine what happens next in a story that's been unfolding for billions of years. We're not spectators anymore. We're participants, and participants have responsibilities. The first responsibility is honesty, admitting when something doesn't fit our models. The second responsibility is courage, following the evidence even when it leads somewhere uncomfortable. The third responsibility is wisdom, understanding that some truths change everything, and everything changed is not always everything improved.
The controversial stuff won't stay controversial forever. Eventually, more data will force conclusions. More observations will narrow possibilities. More objects will arrive or won't arrive, confirming patterns or revealing them as illusions. But right now, in this moment, we're in the space between certainty and chaos. The space where anything is possible because nothing is proven. The space where scientists whisper about alien networks and dead civilizations and galactic highways, because the alternative, that these are just really weird comets, requires believing in coincidences too large to swallow. Something is happening. That much is clear.
What it means, what it implies, what comes next, those answers are still forming. But the questions are urgent, and the clock is ticking. And somewhere in the data we've already collected might be the key that unlocks everything. Or maybe not. Maybe these are just comets. Really, really weird comets. And all the fringe theories and whispered speculations and career-ending hypotheses will collapse into the weight of mundane explanations. Maybe, but I wouldn't bet on it. Not anymore. Not after seeing what's coming next.
Not after understanding that 3i Atlas isn't alone, and we're not alone, and the solar system might be far busier than we ever imagined. The controversial stuff isn't staying controversial, it's becoming necessary. And necessary truths have a way of forcing themselves into view whether we're ready for them or not. What we do with those truths, that's the next question. And it's a bigger question than where these objects came from. It's a question about who we want to be when the universe finally acknowledges that we exist, when the beacons light up, when the network activates, when the next visitor arrives, and the next one, and the next one, and we can't pretend anymore that we're alone in the dark. The controversial stuff is just the beginning. What comes after is transformation, confirmation, contact, or possibly terror. We're about to find out which. Zoom out for a moment. Stop looking at individual objects and start looking at the system as a whole. Because while we've been focused on 3i Atlas and its companion, other things have been happening at the edges of our perception. Small anomalies, subtle shifts. Changes that individually mean nothing, but collectively suggest something is disturbing the normally predictable clockwork of our solar neighborhood.
Scientists monitoring the heliosphere, that bubble of charged particles the sun blows around our solar system, have reported microvariability in solar wind composition that doesn't match standard models. Nothing dramatic, nothing that triggers alarms, just slight fluctuations in particle ratios, tiny deviations in magnetic field strength, small perturbations that could be measurement error or could be something external pushing against the boundary of our system. When you're trying to detect something entering a swimming pool by watching for ripples, you see ripples everywhere. But when multiple independent instruments detect similar ripples at similar times, that's when ripples become data. Think of it this way. Imagine you're sitting in a calm pond and you feel tiny waves lapping against you, small enough to ignore. But then you notice the waves have rhythm, timing. They're coming from a consistent direction. You haven't seen what's creating them yet, but the ripples tell you something is out there, moving through water you can't see, approaching from a direction you're not watching. That's what some heliosphere researchers are beginning to suspect. The ripples have started. We just haven't identified the stone yet. Or maybe we have. We're calling it 3I Atlas. If these interstellar objects are part of a larger stream of material passing through our system, then their gravitational influence, combined with the dust and gas they're shedding, could be creating detectable effects, even at extreme distances. Not large effects.
Solar system dynamics are dominated by the sun and the giant planets. A few interstellar comets aren't going to knock Earth out of orbit, but they could perturb small bodies in the outer solar system. They could add material to the interplanetary medium. They could, if there are enough of them spread along a wide enough corridor, create measurable changes in the environment that we wouldn't notice unless we were specifically looking for them. And now, suddenly, people are looking. 3I Atlas is large for an interstellar visitor.
Some estimates, based on brightness and assumed albedo, suggest a nucleus radius up to 10 kilometers. That's substantial. That's mountain-sized. An object that size, moving at 60 kilometers per second, carries enormous kinetic energy. If it were to hit something, anything, the impact would be catastrophic. But even without hitting anything, its gravitational field and any material it sheds creates a kind of wake as it passes through the solar system, a disturbance in the normal distribution of dust and small particles, like a ship moving through water, leaving turbulence behind. Now imagine not one ship, but dozens, a convoy.
A fleet of fragments spread out along the same corridor, each creating its own small disturbance, each adding its own gravitational pull and dust trail. Individually insignificant, collectively they could create changes in the small body population, alter the distribution of dust in the plane of the solar system, maybe even affect meteor rates if enough material accumulates in Earth-crossing orbits. Some researchers are beginning to ask whether we should expect increased meteor activity over the next few years. Not because 3I Atlas itself will hit us, but because it might be dragging a tail of smaller debris that could intersect Earth's orbit. Meteor showers happen when Earth passes through dust trails left by comets. If interstellar objects leave similar trails, and if those trails happen to cross our path, we could see meteors with unusual properties, high velocities, odd compositions, chemical signatures that don't match anything from our solar system, shooting stars that announce themselves as foreign the moment they burn up in our atmosphere.
Yes, those meteors are from another star system. No, we don't know which one. No, we don't know if more are coming. Yes, you should probably still make a wish. But the implications go beyond pretty lights in the sky. If interstellar material is accumulating in our system, if fragments and dust and particles from other stellar environments are mixing with our own, that has consequences for planetary science. It affects models of how planets form, how systems evolve, how material gets exchanged between stars.
It suggests that solar systems aren't isolated islands, but connected nodes in a larger network of matter exchange, constantly being seeded with material from elsewhere, constantly contributing material to the interstellar medium that will eventually reach other systems. We are not alone. We have never been alone. Not in the sense of intelligent life, necessarily, but in the sense of material exchange. Our atoms came from other stars. That's established fact. But we've always thought of that as ancient history, something that happened during the formation of our system 4.5 billion years ago. What if it's ongoing?
What if every year, tons or hundreds of tons of interstellar material falls into our system, gets captured by planets, lands on Earth, becomes part of our biosphere? What if life itself arrived that way? Panspermia, the theory that life can be transported between worlds on comets and asteroids, is considered fringe but not impossible. If interstellar objects regularly pass through our system, if some of them shed material that lands on planets, then life could have originated elsewhere and been delivered here, not as a one-time event but as an ongoing process.
Seeds from other gardens, falling into ours, germinating, evolving, becoming what we recognize as terrestrial life. This isn't science fiction. This is where the data leads when you follow it honestly. If interstellar visitors are common, if they arrive in streams rather than as isolated events, if they carry material from environments we've never sampled, then the boundaries between solar systems are more permeable than we thought. We're not isolated, we're connected. The galaxy is an ecosystem, and we're one small part of it, receiving inputs from elsewhere whether we notice them or not.
But here's where it gets unsettling. If the boundary is permeable in one direction, it's permeable in both. If material can fall into our system from elsewhere, then material can leave our system and travel elsewhere. Every year, dust from Earth gets kicked into space by micrometeorite impacts. Some of that dust achieves escape velocity. Some of it, over millions of years, will drift to other stars. Other solar systems will receive particles that originated here, carrying traces of our biosphere, our chemistry, maybe even dormant microbes that could survive the journey and seed life elsewhere. We are contaminating the galaxy, or enriching it, depending on your perspective. Either way, we're not passive receivers, we're contributors, part of a vast, slow exchange of matter that's been happening for billions of years. The arrival of 3I Atlas and its companion might be part of that exchange. Materials sent from another system, carrying information about its origin, now passing through ours, leaving traces we're only beginning to detect. But if this is a natural process, why the clustering? Why now? Why in a geometric configuration that suggests organization rather than randomness? That's the question that keeps this from being just an interesting science story and pushes it into the realm of genuine mystery. Because natural processes don't coordinate, they don't align, they don't arrive in pairs with suspicious timing unless something is organizing them. Which brings us back to the disturbing possibilities. If something is stirring in our solar system, if the heliosphere is showing ripples, if small body populations are being perturbed, if meteor rates might increase, if the boundaries are more permeable than we thought, then we need to ask what's causing all this. Is it just the natural consequence of interstellar material passing through? Or is something actively engaging with our system, probing it, testing it, preparing it for something? The optimistic interpretation is that we're witnessing the beginning of a new era of discovery. Our instruments are finally good enough to detect the constant, low-level exchange of material between stars that's always been happening. We're seeing the universe as it actually is, busy and interconnected and full of movement, rather than the sterile void we imagined. Every unusual observation, every anomaly, every ripple in the data is evidence that space is more interesting than we thought. That's exciting. That's science at its best. The pessimistic interpretation is darker. If our solar system is experiencing increased activity, if multiple interstellar objects are arriving in coordinated ways, If the boundaries are being tested or crossed more frequently, then maybe something is coming. Not just debris, not just fragments, but something intentional. A wave of material that's the leading edge of something larger. An invasion not of armies or fleets, but of matter itself. The slow transformation of our system from its current state into something else. Seeded and changed by external inputs we can't control. That sounds like paranoia, like conspiracy thinking, but consider if an advanced civilization wanted to alter or terraform a solar system, you wouldn't send ships. Too expensive, too slow, too detectable. You'd send seeds. Self-replicating machines or organisms, small enough to slip past defenses, capable of using local materials to build copies of themselves. You'd scatter them across the galaxy and wait. Eventually, some would land in systems with the right conditions. They'd activate. They'd begin changing things, slowly, subtly, building infrastructure, or altering chemistry, or preparing environments for whatever comes next. By the time the local inhabitants noticed something was wrong, it would be far too late to stop the process. Is that what's happening here? Are these objects scouts? Are they seeds? Are they the beginning of something that won't become obvious until it's irreversible? Or am I just scaring you with remote possibilities because the real answer, that these are natural objects behaving oddly, isn't satisfying enough? That's the problem with anomalies. They create space for speculation. And humans are really, really good at filling spaces with fears.